Hi everyone, my name is Alex Ramsden and I will be taking you through a problem from chapter 17. It is a titration of a weak base with a strong acid, and it is problem number 73 on page 832 of the textbook. So the question is, consider the titration of a 25 milliliter sample of 0.175 molar methylamine with 0.15 molar hydrobromic acid. Determine each quantity. Part A is the initial pH. So for this part, we know that methylamine is a base, so it's going to accept a proton from water to produce OH. So we start by writing the reaction for this equation, which is methylamine plus water turns into the methylammonium ion and OH minus. So we start by writing our initial concentrations that are given by the problem. We've got 0.175 molar methylamine, and then there's no concentration of either of the products. And our change is going to be minus x and then plus x for both of the products in this reaction. And we write our equilibrium expressions because we are going to be starting with the concentration of methylamine and then subtracting x from those, and then we get x for both of the products. So now we write an equilibrium expression given the Kb value for the base of methylamine that we find in the back of the book. That value is 4.4 times 10 to the negative 4. So we write the equilibrium expression as Kb equals the concentration of both of the products over the concentration of the reactant, and we get that that's 4.4 times 10 to the negative 4 equals x squared over 0.175 molar minus x. And I did the expression out like this because we're going to have to solve a quadratic for this part of the problem. So we set everything equal to 0, and then we plug those values into the quadratic equation, and we get that x equals 0.00855, which is giving us the concentration of OH minus, as we can see from above. That is the x right here. So the x value we solved for before gives us the concentration of the OH minus in the products. So now we can solve for POH by doing negative log of OH. And we get that is POH equals 2.068. And then the question asked for pH, so we do pH equals 14 minus POH. And then we solve for the pH, which equals 11.93. So to summarize problem A, we have to do a Rice table for the methylamine and solve for the concentration of the OH minus using the equilibrium expression. And then we use that OH minus to solve for POH, and then we can solve for pH. So moving on to part B, the question is the volume of added acid required to reach the equivalence point. So we know that at the equivalence point, the moles of acid are equal to the moles of base in the titration. So to do this, we can do M1V1 equals M2V2, but I put subscripts of A and B to show that it's the acid and the base. And then we just plug in the known values from the original problem. So we've got the molarity of the acid times what we're solving for, which is the volume of acid, equals the molarity of the base times the given volume of the base. And then when we solve for VA, we get 0.029167 liters, and I translated that into milliliters, so you have 29.2 milliliters of acid required to reach the equivalence point. So for B, all you have to do is M1V1 equals M2V2 with the given values, and then solve for the volume. Then part C asks for the pH at 5 milliliters of added acid. So for this part, we must calculate the initial moles of methylamine that we're starting with. So we do the volume, which is 0.025 liters, times the molarity, and we get that we're starting with 4.375 times 10 to the negative 3 moles of methylamine. And then we have to calculate the moles of HBr that we're adding. So we're adding 0.005 liters of 0.15 molar HBr, so that is 7.5 times 10 to the negative 4 moles. So I've set up the reaction for the titration here, and you can see that we've got the methylamine plus the H plus ions from the hydrobromic acid turns into the methylammonium ion and the H2O. I have a mole table here showing the initial moles of the methylamine, and then the moles we're adding of H+. And to get the final moles, we did the methylamine minus the H+, because for every mole of methylamine, it's reacting with 1 mole of those H+ ions in order to produce 1 mole of the methylammonium ion. So that's why the final concentration of the methylammonium ion is the same as the moles of H+ that we added. So now we have to find the molarity of the two substances, and to do that we take the moles that we just solved for and we divide it by the total volume. So we have to take into account the initial volume of the methylamine and then the added volume of the hydrobromic acid. So we do that for both of these, and because we now have the molarity of a base and a conjugate acid, we can use the Henderson-Hasselbalch equation, which we know is pH equals pKa plus log of base over acid. And the initial problem we only had Kb, so we use that Kb expression and can solve for Ka using Kw equals Ka times Kb. So as you can see here, we use Kb to solve for Ka and get that Ka equals 2.273 times 10 to the negative 11. And then when we plug that in along with the molarities, we can solve for pH, and we get that the pH equals 11.33 after adding 5 milliliters of hydrobromic acid. So for part C, all you have to do is find the moles of each substance and then find the molarity of each one and make sure that you use the volume after adding the acid, and then you can use the Henderson-Hasselbalch equation to solve for pH. So now moving on to part D, we are looking for the pH at 1/2 of the equivalence point. So we know that at half of the equivalence point, pH equals pKa. So we can use the Ka that we solved for above, which is 2.273 times 10 to the negative 11, and we simply do the negative log of that to find the pKa, and we get that pKa is 10.64, so that's the same as the pH, so the pH is 10.64 as well. So for this one, all we have to do is take Ka and solve for pKa, and that will give us the pH. Now moving on to part E, we're looking for the pH at the equivalence point. So the equivalence point is when moles of acid is equal to moles of base. So from part C, we know the moles of acid, we know the moles of the base methylamine that we have, so we must also have that amount of acid being added in the hydrobromic acid. So we do this expression out, which is the titration, and we use up all of the reactants, and so the only thing left in the solution at this point is the methylammonium ion, and it's present in the same amount of moles as we added of each of the reactants. So we must find the molarity of this methylammonium, and in order to do that, we take the moles of it and divide by the overall volume. So we take the initial volume plus the volume of added acid, which is from part C, and we get that it's 0.0807 molar methylammonium ions. So now that we are at the equivalence point, all of the original reactants have been used up, and the methylammonium ion is actually going to move in the reverse direction to produce H3O plus ions and methylamine again. So here's a rice table with the initial concentration that we just solved for of the methylammonium ion, and we're doing just minus x plus x plus x as we've done before, solving for the x value. So we set up the equilibrium expression shown here, and we plug in our numbers, and in this case we can actually ignore the minus x because our Ka value is less than 3 times 10 to the negative 5, and our x is greater than 0.01. So I've done that out here, and we solve that x equals 1.354 times 10 to the negative 6, which is our concentration of H3O plus that is produced. So then we just take the concentration of H3O plus, plug it into the pH equation, and we get pH equals 5.87 at the equivalence point. So for part E, you figure out the moles of methylammonium ion that are produced when the reactants are all used up, and then you find the molarity of this methylammonium ion, and then you use the rice table and the equilibrium expression to find the concentration of H3O plus when the methylammonium ion goes in the reverse direction, and then use that concentration to solve for pH. And the final part of the problem is to find the pH after adding 5 milliliters of acid beyond the equivalence point. So for this, we know that the volume of hydrobromic acid at the equivalence point is 29.2. So we calculate what it must be at 5 milliliters past that, which is 34.2 milliliters. We solve for the moles of HBr that we're adding. So we take that volume times the molarity of it and get the moles of HBr. And then we take the moles of HBr, and we know that they must be reacting with all of the methylamine, which was 0.004375 moles. So we take the moles of HBr minus that, and we get that we have 0.0075 moles of H plus ions left over. So we take that, so we have to solve for the concentration of H plus ions. So we take those moles we just calculated and divide by the total volume after we've added 5 milliliters past the equivalence point, and we get that it is 0.01275 molar H plus. And then we plug that into our pH equation and get that the pH is 1.90 at 5 milliliters past the equivalence point. So for F, you just find the moles of each substance and see how many moles of H plus are left over. Then you find the molarity of the H plus and solve for pH. So that's everything I have for problem 73 in chapter 17. If you have any questions, feel free to reach out to me.